Assalamualaikum warahmatullahi wabarakatuh. My name is Wan. I'm engineer BNP20803, matrix number AN240041. We are from group 2, section 3. Okay, now we want to present about a group project for subject BNP20803, structural analysis and design. Okay, for the group members, first is me, Wan Aiman Dinier bin Cik Wasabri, as a structural modeling and drawing. Okay, next we have Wan Khairul Aslam bin Kamarudin as a structural analysis, and Clever Dikaran Stephen as a structural design and engineering solution. And next for Nur Izzah Izzati binti Saudun as a site measurement and data collection. Okay, for the last one is Nurul Nadia binti Khairul Umar as a project coordinator and report compilation.
My name is Nur Nadia binti Khairul Umar. First, we will see the introduction of our project. Structural analysis and design ensure that structure can safely resist applied loads. This project focuses on the measurement, modeling, analysis and design of reinforced concrete beams, slab and columns at Arcade Mawar UTHM Pagu using Eurocode 2 standards. Site issues were also identified and appropriate engineering solution were proposed. I will explain about our objective for this project. First, to conduct measurement of structural elements at UTHM Pago site, which is Cafeteria Arcade Mawar. The second one, create 2D and 3D structural drawings with engineering software, such as Revit and STEAM. The third one, structural analysis and determination of design loads. And for one, to design the reinforcement of beam, slab, and column in accordance with Eurocode 2. Lastly, determine structural problems and provide engineering solutions. So, our group have choose Cafeteria Arcade Mawar, campus UTHM Pago as our site location. Why we choose this location? Because its easy accessibility and clear reinforced concrete structural elements, including beams, slabs, and column. Site measurements were collected and used to develop structural drawings, perform structural analysis, and carry out reinforced concrete design in accordance with Eurocode 2 standards.
So next, I'll explain about data measurement. First, we have beam. So for the beam, we have 9,999.98 millimeter times 1,976.12 millimeter times 264.16 millimeter. Next, we have columns. So for the measurement, we have 5,450 millimeter times 360 millimeter times 660 millimeter. And the last one, we have slab. So for the measurement for slab is 11,320.78 millimeter times 10,719.82 millimeter times 266.7 millimeter.
Okay, for this project, we provide 3 software 3D drawing, which is we have a Revit, AutoCAD, and STEAM. For Revit, AutoCAD software just like same, but for STEAM, we can get a calculation from STEAM.
Hi, my name is Clever Dikaran Stephen. So this is our comparison of dimension of our project. So there will be 2 SEMDABI and also assume measurement. During the site measurement, we only use phone and also measuring tape. So there will be an error during the taking measurement. So this is our measure dimension. For main beam, SEMDABI is 8,400, 300, and 800. For our data, we get is 9,999.98 millimeters, 1,976.12, and 264.16 millimeters. For secondary beam, from SEMDABI is 9,600, 300, 800. For assuming measurement, for secondary beam is same because we assume the 2 beam have the same length, wide and high. So that's why we put same down there. And for column is for width and height is 300, 600. Meanwhile, for length, same W for column is 3000. For column, we taking is 360 for wide and 660 millimeters for high. For the length is 5450 millimeters. And then for slab, we get 9600, 8400, and 336 millimeters. For our SU measurement is 11,320.78 millimeters, 10,719.82 millimeters, and 266.7 millimeters.
Okay, so we will talk about the analysis of structure for the beam. So as you can see, the result for the SIMW, for the SU measurement and for the STIM is all different. As you can see from the shear force, from the bending moment, and for the main rebar, it's all different. This is because the span is different, because the SU measurement we took 10,100 millimeters, and for the SIMW we took the 8,400 millimeters, and STIM it took 9,600 millimeters. The STIM took the long span, but we calculate the short span for the beam, so the result will be different.
Okay, for analysis of structural for slab, we have SIMW, SU measurement, and also STIM. So for short span and long span, for SIMW is, as we know, 8,400, 9,600. Meanwhile, for SU measurement, we get 10,720 millimeters, 11,320 millimeters, and for STIM is 4,200, 9,600. For shear force, for SIMW is 75.054 kilonewton per meter. For SU measurement is 140 kilonewton per meter. For main rebar, for SIMW they use H12 150. For SU measurement is H12 70, and for STIM use D10 250. For short span moment, for SIMW we get 93.307 kilonewton meter. For SU measurement, we get 54.88 kilonewton per meter. Thank you.
Next is the structural analysis for the column, that using three methods, which is SIMW, SU measurement, and STIM. Based on the slenderness ratio, both SIMW and the SU measurement classify the column as non-slender because the values are below the allowable limit. For the effective length, the SU measurement gives the largest value, while SIMW and STIM provide shorter lengths. And looking at the bending moment, SIMW records 31.29 kilonewton meter. The SU measurement gives 55.51 kilonewton meter, and STIM has the highest value at 176.5 kilonewton meter. So for the axial design force, the values are 285.56 kilonewton, 240.29 kilonewton and 321.6 kilonewton respectively, with S-team again producing the highest result. Overall, the columns are considered non-slender, but the calculated loads vary depending on the analysis method. The assumed measurement were estimated using a phone, so the result may not be fully accurate. So next is analysis. These slides explain the main reason for the differences between our analysis and the Sime Darby design. First, measurement limitations. It may have caused small difference because our site dimensions were estimated manually and may not exactly match the actual measurements. Second, we had limited project information. Our calculations were based mainly on site observations, while some Darby used detailed engineering drawings and design data. Third, we had different design assumptions, especially for the applied loads, which affected the final structural calculations. Lastly, structural optimization also contributed to the differences. Some Darby's design was optimized to meet safety standards, performance requirement, and construction efficiency. So overall, these factors explain why our calculated values are different from the actual design result.
Okay, next I want to tell about challenges and engineering solution. At first, we have a structure access. Challenge, components hidden by ceiling and service. Direct measurement was restricted. For solution, we have conduct predict visual inspection and utilize BIM digital system for records. Okay, next is a busy site environment. Challenge, cafeteria was highly crowded with constant student traffic, limited workspace. Okay, for solution, perform a strict load control assessment to handle high occupancy lift loads safely. Okay, next is a measurement tolerance. For the challenge, minor data discrepancies occur due to site access and physical scale constraints. For the solution is establish a preventive maintenance schedule, crack repair and surface treatments. Okay, for the last one is internal reinforcement. For challenges is steel rebars were encased in concrete. Physical verification was impossible. For the solution is a base detailing and design assumption strictly on existing drawing and Eurocode 2.
Finally, for the conclusion, this project successfully complete the measurement, modeling, analysis, and design of reinforced concrete element at Arcade Mawar Utesh and Pago. This design comply with Eurocode 2 requirement and were verified using S-team software. Overall, our project improved practical knowledge of structural engineering, reinforced concrete design, and engineering software application. That's all from us, Group 2. Thank you.
And that's all from Group 2. Thank you.